Hello again from Skip, Victor Echo 6, Bravo, Golf Tango. Well, here's the final part of the project, part 3 of the transverter control I've been building for Howard, G4CCH. Very neat little unit. In part 2, I was showing the evaluation version of this, where I had the pick on the evaluation board and all the jumpers going to the LEDs to indicate what's what, just to get the code written. Well, we've gone a step farther now. So working back and forth with Howard, we've only got the final concept figured out, and this is the schematic for it. One thing that's been added is this programmable attenuator module, which is at the bottom of the schematic, and it's going to control the output from the local oscillator only for certain bands. So it's a done deal, and about getting into building the circuit board next. So working back and forth with Howard to find out just where he would like the outputs in this board and how we can match them up with the pick output pins. I came up with this layout. Luckily, I could rewrite some of the code and rename some of the pins so that things lined up better, and it works out well that way. With the final board layout design done, I just remove all the part symbols and stuff, and I'm left with what's over, which is going to be the copper foil layout for the clear transparency. I was having some UV light exposure issues earlier, but I think I've got it under control now. This is a picture of the board after it has been exposed and then run through the developing tank, showing what's left over for the emulsion. Wait now to stick it in the etching tank and eat the bare copper off. Here's a picture of the board in the ammonium persulfate tank. It's diluted with water and heated at 40 degrees centigrade. I watched it as it slowly ate copper away, which took about 10 minutes all told to have it fully done. So when I'm satisfied with what the etchant's doing, I pull it out of the tank, wash it off, and this is a picture of it with the emulsion still on. I take that off some thinner, lacquer thinner, and then I put it through a tinning solution, and gives it a nice covered surface, which is easy to solder to. Ready to put parts on. That was the fun part, getting all the itty-bitty parts put on, all surface mount. The group of small solid-state relays and diodes and lots of LEDs. This is the board finished, and only left now is getting the large pick on there and make sure it loads properly, and then on to testing. So this is it on the workbench. I'm using a full-size 5-inch Nextia on screen now instead of the smaller one I had before, so I could have all the icons sized properly and all hooked up, ready to go. Okay, so we're going to test this unit out. We're going to switch on the power. And you see all the LEDs come on as a test, which we'll take out of the code here eventually. Anyways, here's the splash screen with Howard's call and stuff, and we'll touch it, and we'll get up to the main operating screen. So, first thing we'll do is enable the transmit output. It takes care of that part, so we'll go through this quickly. I'm not going to do every band. We'll go to the 1296 first off, and you see the associated lights come on. Now, I'll take the ground wire here, and ground, you'll see the transmit light on 1G3 here come on. So that's our indication output. Go to the next band, 2320. You see all the other lights come on, indicating it's doing quite a function change in the multi-band transfer Howard built. Again, transmitting. This time's on 2G3. And so on and so on. We'll go to 2301. Not much difference there, but same thing again. Transmit. 2G3. Oh, now we'll go over to the crossband. One of these. Go to 2400, say. First off, we'll go simplex 2400, receive 2400 transmit, and back. And there's lights, all the LEDs configuring what's going to go where. Hit the push to talk, and 2G3. Now it's simplex. So, and it's all showing we're out of band. Going to be transmitting out of band according to the warning. So now we'll go back into 2400. We'll go crossband 2400 to 2320. And back. So now this time, when we transmit, you'll notice we're okay. Because we're transmitting 2320, which is allowed. So we're going crossband from 2400 to 2320. And you can see the LEDs changing here, going from one frequency to the other frequency, and the transmit light coming on. So that's how that works. Now if I go to, let's say 3400, which is a straight channel, or band I mean, it's pretty straightforward. Hit the push to talk. Again, same thing, only this time is the 3G4 LED coming on for that 3400 megahertz part of the output circuit of Howard's. 3398 is a crossband also, or simplex. Let me get it going here. Here we go. We'll go crossband. 3398 to 3400. Go back out, and that's allowed if I recall. And it shows it transmitting. Red indicator on the LCD screen. So we're green receive, and whoops, hit the camera. And oh geez, I'm trying to say red for transmit. Now if I go back here again, go 3398, 3398 simplex. I believe we're okay that way. No, we can't transmit at 3398, we can receive. So that's how that works. Anyway, then 5760 6nm band, same thing. Transmits on and off. It's pretty straightforward. The next part is the interesting part of this now. It's the local oscillator module button here. We'll push it. And I go up here. Now this is indicating the 3 bands that Howard needs to adjust. Probably only once, but it's for 13 centimeter, 9 centimeter, and 6 centimeter band. It's an attenuation model. It's going to, if I recall him telling me, is going to adjust the output drive from the local oscillator. So right now it's set for 11.5 for 13 centimeters, 10 for 9 centimeters, and 7.5 for 6 centimeters. Just random numbers I've put in there. If you want to adjust this, now you watch the LEDs on the right hand side of the board down there as I adjusting. See how they're changing? So we're adjusting that. It's a logic table. We're adjusting that attenuation module as we go along here. Say we like 6 dB for 13 centimeters. Hit the 13 centimeter button. It saves at the EEPROM, and it's good to go. Want to do one of the other bands? We'll say we'll go up to 7.5 dB for the 9 centimeter band. Again, just push the button. It says saved, and it's saved. So say we're all done. You go back out. So remember 6, 7.5. Go back out here again and go back in. Still showing 6, 7.5. And you can adjust this thing. Anyways, it saves at the EEPROM, and it'll be there forever. Either you adjust it again, or if you were to dump new code into the PIC itself, of course, it goes back to a default value. Anyways, that's how he's going to adjust it. So it's kind of a nice way to set things up. So you can see how things adjust on those far right-handed LEDs there. It's going to I can't remember the make of it, but it's an attenuation model anyways, and it has a logic table which goes in and lets you do things. If you don't save it, it won't affect it. Go back out again. Now if I hit 1296, it sets that attenuation model to 0 because it doesn't want attenuation, but it goes back to where it was before, or where it's being saved at, sort of thing. So anyways, that's the basics. That's how it works. Hit the little star here in the corner, and we're back to the splash screen. So it's all done. It's up to Howard now to I got to send it to him, get Howard to get it in his multi-band transverter, and hopefully she works. So that's all there is.